Okay, in this video, I am going to give you two example problems. So the first one is SAT score. The SAT is an exam used by college and universities to evaluate undergrad applicants. The test score is normally distributed. The average math SAT score is 600, so mu is equals to 600. And then standard deviation is equals to 80. Suppose a student is randomly selected, find the following probability. So A is the probability that the score is at most 510. So at most means the maximum is 510. What is this probability? First, you have to standardize the 510. So we do this. X is not X anymore because we have to start the standardization. So this is a Z less than or equal to, we take 510, subtract the mean, divided by standard deviation. Remember this formula. We have Z equals to X minus mu divided by sigma. That is how we standardize a number. So what is standardized means? Standardized means we are going to compare 510 to everybody who took the same test. All right, and then that equals to a number, right? So probability Z is less than or equal to, how do we do this in our calculator? This is how I do it. So I use a parenthesis. I do everything in one step. Parenthesis 510 minus 600 close parenthesis, and then divided by 80, and then hit enter, negative 1.125, and then I draw the calculator command, that is a normal CDF from negative infinity to negative 1.125, and then 0 and 1. The graph is this. You have a bell curve, and the mean is equals to 0, negative 1.125, and then you have a left-hand side. That is the probability that you are looking for. So go back to the problem. So what is that equal to? You go to second vars, and then you select normal CDF. Negative infinity is, you type negative 1 first. Again, the negative sign is between the decimal key and the enter key. Negative 1, second comma, you get the E, and then 99, comma, negative 1.125, 0, 1, close parenthesis, and then you get a probability 0.1303. So that is your probability. There is another way to get this. So there is one other calculator command that helps you to get to this answer without showing any work. So let me show you that command. That is a normal CDF. You don't start at the Z, you start at the X. We start at the 510. So less than or equal to 510, that is negative infinity to 510, and then the mean is, what is the mean? Is the mean 0? No. Before standardization, the mean is sigma. And then the standard deviation is 80. Again, this is before normal standardization, mu and sigma, before standardization. All right, it's no longer 0 and 1 because the 510 is X. So that gives you the same answer too. So let's go ahead and take a look. We do second vars, and then normal CDF. We have negative infinity, and then to 510, mean is 600. The standard deviation is 80. Close parenthesis, and then we hit enter. See, you get the exact same thing. You get the exact same thing. All right, let's do another one. The next one is at least 750. So B is probability that X is greater than or equal to 750. So first we standardize, change the X to a Z, and then this is a X minus mu divided by sigma. And then we calculate what it is. So Z is greater than or equal to, we have parenthesis 750 minus 60, and then divided by 80. You do everything in one step, 1.875. And then the calculator command is normal CDF from 1.875 to positive infinity, and then 0, and then a 1. The mean is equals to 0. Z is 1.875. All right, and then what do? You do this in your calculator, right? So you go to second vars. No, that is not right. So let's go back. Okay. Second vars, normal CDF, and then we have 1.875 to positive infinity 1 second comma to type the E, and then 9901. Enter. So that is 0.0304. That is your answer. What is the shortcut? The shortcut is you use the greater than or equal to 750. You do normal CDF from 750 to positive infinity. The mean is 600. The standard deviation is 80. Again, this is before standardization. The mu is 600. The standard deviation is 80. This is after standardization because we have C. Mu is equals to 0. Sigma is equals to 1. All right, you do this, you will get the same answer. Let's try that one. Second vars, and then select normal CDF. You have 750 comma positive infinity, and then 600 comma, and then 800. So this is equals to 0.4256. Did I do something wrong? 750. Oh, 600 and 800. It is supposed to be 80. Oh, by the way, now is a good time to mention this. This is wrong, right? It's a good time to mention this. I type 800, but it is supposed to be 80. I am lazy. I don't want to type the same command again. How do I get the previous command out and then just edit the command? The answer is you go to second, and then you type the enter. Second, and then you type the enter key. Do you see the word entry above enter in the upper left hand corner? You type that, you get the previous command, you move your cursor to the, this is different from a TI-84 graphing calculator. When you move the cursor, just move the cursor on a 0. So the 0 should be flashing. And then you click the DEL, the delete, just right on the right side of the mode key, delete. And then you will be able to delete the extra 0. So see, this gives you the same answer. All right, moving on. Let me pull my notes out so I don't need to keep going back to the first page. Okay, in part C, between 500 and 650, probability that X is between 500 and 650. Okay, exclusive, then you don't use the equal. But is that really important? The answer is no, because X is a continuous random variable. Putting an equal versus no equal, that makes no difference because X is a continuous random variable. All right, so let's do the standardization. So that is equal to probability 500 minus what is the mean? The mean is 600, and then divided by 80 less than Z. We started the standardization is no longer X. 650 minus 60 divided by 80, and then we calculate that. So this is how I do it. I use parentheses 500 minus 600 divided by 80, and then you got this, right? Negative 1.25, and then I do second enter. you see this pops out again. I have to change the, forgot a 0. It's 650 minus 600, right? And then I change this to 650. So this one is delete and delete. So 650. Oh, looks like they don't let me do that. Okay. Might did something wrong. All right, I will just type a new one. 650 minus 600 divided by 80, 0.625. And then the command is normal CDF, negative 1.25 to 0.625, and then 0.1. So second was normal CDF, and then negative 1.25, comma, 0.625, comma, 0, comma, 1. That is 0.6284. That is your probability. And then the graph, let's quickly draw the graph over here. The graph, you have 0 in the middle, negative 1.25, positive 0.625, and then the 62% is right between them. So that's the area that you are looking for. And then next one is no more than. What is the opposite of more than? The opposite of more than is less than or equal to 300. No more than, right? The opposite of more than is less than or equal to, but the equal is not important at all because x is a continuous random variable. That answers the next question. Is the equal or not equal important? No, because x is a continuous random variable. So that is the C, less than or equals to 300 minus 600 divided by 80. Alright, so 300 minus 600 divided by 80. Okay, Mr. 3, we type that 300 minus 600 divided by 80. Negative 3.75. The probability must be very small because that push almost all the way to the right. And then that is normal CDF from negative infinity to negative 3.75. The mean is 0. Standard deviation is 1. The graph is this, 0. And then negative 3.75. The probability is so tiny if you use a perfect scale. Second was normal CDF, negative 1 second comma 99, and then negative 3.75. I type everything right? Yep. 0, 1. All right, everything is good. So this is 8.84. Is this right? No. Times 10 to the negative 5. That means the probability is very close to 0. So if you want to see the decimal, that is 0.40884. So that is very close to 0. What is the shortcut to do this? The shortcut to do this is you do normal CDF, and then you go from negative infinity to 300. The mean is 600. The standard deviation is 80. You will get the same thing. All right, I just find out that I forgot to do this for the previous one. So let's go back to the previous problem. I'm going to change color for that so that it's easier for you to see. The shortcut is normal CDF from 500 to 600. The mean is equals to 650. The mean is 600. The standard deviation is 80. That gives you the same answer. All right. So overall, in part E, is the equal or not equal important? The answer is no. That is not important because x is a continuous random variable. Okay, after this, I have 2 more subproblems for you to do. The next one is the 10 percentile. So you take SAT, right? let's say you are apply for a really good college and they only accept the top 10%. How many points do you need to be the top 10%? How do you find out? Do you compare yourself with your friend? Do you compare yourself with everybody in your school? No, that is not true. When you look for the top 10% of a test, you compare yourself to everybody who took the same test on the same day. All right, you compare one person, which is yourself, to everybody, maybe millions of people. So the next part is, let's pick another color for that. I want to find the top 10%. How many points do I need to be the top 10% based on this distribution? All right, so the top 10%, here is how we do it. We start with a graph. After standardization, mean is equals to 0. This is your top 10%. First, I need to find the standardized score. The top 10%. So this Z is inverse norm 0.10. The mean is 0. Standard deviation is 1 because that is after standard normal. And then you quickly do that. Second was inverse norm 10%, 0, 1. Okay, in case you don't have such thing, you have a very good TI-84 CE, you see a menu. Don't worry about this. All you have to do is type these three numbers in this order. They are trying to walk you through everything. They ask you, okay, first number, you have to type the area. Second number, you type the meal. The third number, you type a 1, and then you paste. So you paste this command over to your home screen, press enter, and then you will get the answer. All right, so we have negative 1.282. This is on the right hand side, so this is a positive. The Z that we want is 1.282. This is on the left, this is on the right. Okay, so this is the Z that we want. Is this done? Do I only need to get 1.2 points on SAT to be the top 10%? That sounds too easy, right? Nope. This 1.282 is only a standardized score. 1.282 means to be the top 10%, you must be 1.282 standard deviations above the mean. It doesn't mean you only need 1 point on the test to be the top 10%. How do I get the actual score, the raw score, the score that you receive? You don't receive a 1, right? You receive like a couple hundreds. What's that score? So that score is, you have to take X, that is what you are looking for. You subtract the 600, right? The mean is 600. Yep. And then divided by 80 equals to 1.282. And then you have to solve this equation. So X is equals to 1.282 times 80, right? You multiply 80 on both sides, and then you add 600 to it, then you get your answer. So 1.282 times 80, and then plus 600. So you need 702.56 points or above to be the top 10%. If your score is 701, you are not the top 10%. If the school only consider the top 10% and you have 701, unfortunately, you are not qualified. All right? Okay, this one is the second problem. I know I have one more part to go, so I'm going to bring this down a little bit so I can get some space for the next one. The last one that I asked for is the 20th percentile. Usually no one cares about this. Without the word upper, in this one I asked for upper 10%. Without the word upper, just a percentile, that will be the bottom 20%. No one cares those people, right? But the bottom 20%. So the bottom 20% would be 0, 20% right here. That would be the bottom 20%. And then what is this Z? This Z is inverse norm 0.20%, 0 and 1. So inverse norm 20%. Second was inverse norm 0.20, and then 0 and 1, what do you have? You have negative 0.842. Do we remove the negative? No, we don't, because this z is on the left side. We don't need to remove the negative. And then you set up the equation. I don't know what that score is. I subtract the mean divided by the standard deviation, that equals to negative 0.842. So that is how you set up the equation, and then you solve it. So x is equals to negative 0.842 times 80. You multiply 80 on both sides, right? So imagine this. Let's say you don't really get it. X divided by 6 equals to 12. How do you solve it? You have x equals to 12 times 6, right? Let's say x minus 1 divided by 6 equals to 12. You do x minus 1 equals to 12 times 6, and then x is equals to, that is 72 plus 1. That's how you solve it. So back to this problem, all you have to do is you add 600 to it. So negative 0.842 times 80 plus 600 to it. Then you have 532.64. So that is the score. So to be the bottom 20%, you need to get this score or below, right? So that's how to answer the percentile problem. So in the next example, we do one more problem, because one example is never enough. So we do one more problem. So this is a police response time. Police response time to an emergency call is the difference between the time the call is first received by the dispatcher and the time patrol car radios that it has arrived at the scene. Over a long period of time, it has been determined that the police response time has a normal distribution with mean equals to 9. Let's pick a color that I don't really use. Let's pick purple. So mu is equals to 9, and then standard deviation is equals to 2. Wow, the purple is pretty hard to see. Let's pick something else. Let's pick blue. So mu is equals to 9, sigma is equals to 2, much better. All right, between 6 and 10. So A is probability that x is between 6 and 10. 6, x, and 10. 4 significant digits. Let's change that. 4, just do 4 decimal places. That makes much more sense. 6 and 10. First, we standardize. So this is 6 minus 9, right? 9. Divided by 2 less than x, less than 10 minus 9 divided by 2. So that is 3 divided by negative 3 divided by 2. And this is 1 divided by 2. So this is our graph. 0, negative 1.5, and then 0.5. And then you have that. And then the calculator command, so you have normal CDF from negative 1.5 to 0.5. The mean is 0. The standard deviation is 1. Or what is the C mean? The C means cumulative. Okay, cumulative. C, cumulative density function. When you do this, you are asking the calculator to approximate the area for you. If you take PDF, you are looking for a specific point on the graph. That is what we are not what we are trying to find. We are trying to find an area. Okay, so let's clean this up. Second was normal CDF, negative 1.5 to 0.5. Mean is 0. Standard deviation is 1. We have 0.6247. So that is the answer. And then B is no more than 5. So B is no more than 5. Probability that the opposite of more than is less than or equal to. So we do x the z less than or equal to 5 minus the mean divided by 2. So that is negative 4 divided by 2. Negative 4 divided by 2 is equals to negative 2. 0, negative 2, less than means left side. Less than is left, greater than is right, between is in the middle. And then you have normal, CDF, from negative infinity to negative 2, 0 and 1. So second bars, normal CDF from negative infinity, second negative 1, and then second comma 99 to negative 2, and then 0, and then a 1. You have 0.0228. I know I forgot to do the shortcut, right? So the shortcut, one command to get straight to the probability is normal CDF from negative infinity to 5. The mean is 9, the standard deviation is 2. Because we are taking x, x is before standard normal. X is before standardization. Z is after standardization. So this is one command to give you the same answer. The previous one. So one step is normal CDF. We have oh, by the way, this is a Z. This is a Z. We have 6 to 10. The mean is equals to 9, the standard deviation is equals to 2. Part C. No less than 12. The opposite of less than is greater than or equal to 12. Then this is the Z, greater than or equal to 12 minus 9 divided by 2. So that is a 3 divided by 2. 3 divided by 2 is 1.5. And then you have normal CDF from negative infinity. Actually, nope. That is from 1.5 to positive infinity, 0 and 1. So we have that. This is a 0. 1.5. 1.5 greater than or equal to, that is your area. And then let's do this in a calculator. Second vars, normal CDF, 1.5 to positive infinity, 1 second comma 99. The mean is 0, standard deviation is 1. So that is 0.0668. That is the area. The one-step command is normal CDF. We start from 12. So that is 12 to positive infinity. The mean is not 0. The mean is 9. The standard deviation is 2 because this 12 is before standardization. And then we have 2 parts left. The top 18%. The top 18% means the fastest. The top 18% is actually, I think, is the longest time. Let's get the answer first. So D is the top 18%. So the top 18%, we have 0. 18% right here. 18%. This is a Z. So Z is equals to inverse norm 0.18, 0 and 1. Let's find out what this is. Second vars, inverse norm 0.18, 0 and 1. That is negative 0.915. Is on the right side, right? So this is on the left. The one on the right is positive 0.915. It's not done. This is only a standardized response time. We have to get the actual response time. So x minus 9 divided by 2 equals to 0.915. So x is equals to 0.915 times 2 plus 9. So let's take a look. 0.915 times 2 plus 9. That is equals to 10.83. So 10.83 is actually above 9, right? So that is above average. So this one is actually not the fastest response time. This one is the longest 18% response time. Is greater than or equal to 10.83 minutes. So that is a bad thing, right? The police take a long time to be arrived to the scene. The last one. The last one is only a 12 percentile. So 12 percentile without the word upper. If you just see the percentile, that means 12% on the left. If you don't remember what this is, remember the box plot. What is Q1? Q1 is the first 25% of the data, right? It's the first 25, not the middle, not the last. Same idea right here. 12% without the word upper. That means the 12% on the left. Zero. 12%. Z. So Z is equals to inverse norm. 12, 0, and 1. So second vars, press the wrong key, second vars, and then we have inverse norm, 0.12, and then mean is equals to 0, standard deviation is equals to 1. We press enter, negative 1.175. Of course, that is only a standardized value. So the actual value is x minus the mean, which is 9, right? 9 divided by 2 equals to negative 1.175. Don't worry about the negative. The 9 is big enough to make it positive. So x is equals to negative 1.175 times 2 plus 9. Negative 1.175 times 2 plus 9. 6.65. So this is actually the fastest 12% response time, which is a good thing. When you call the police, you want them to be here immediately, right? So the fastest 12% is less than 6.65 minutes. The longest 18% is greater than 10.83. They are all in minutes. They are x, right? X has a unit. They are all in minutes. So that will be all in this video. I will wrap this up. I see you all in the next video.